So imagine just a single human mind, right? Like trying to process the simultaneous reality of completely revolutionizing global digital payments and then upending the entire legacy automotive supply chain with electric vehicles.
Oh, and don't forget battling the military-industrial complex to build reusable orbital rockets.
Right, exactly. And now, on top of all that, writing the neural net architecture for humanoid robots and brain-computer interfaces. I mean, it completely shatters the normal boundaries of human cognitive load.
It really does, because, when you look at the trajectory of most massively successful companies, there's usually a very linear progression.
Yeah, you build a core competency and then you just sort of expand adjacently.
Yeah.
You definitely don't jump from digital banking to orbital mechanics and then to like brain surgery.
No, you don't. It's a total architectural violation of how modern business and engineering are even supposed to work. Like the conventional wisdom is always hyper-specialization.
Right. Dedicate your whole life to one narrow vertical.
Exactly. So to operate at the absolute frontier of 4 or 5 wildly different, super capital-intensive hardware industries all at once, it suggests there's an underlying operating system there.
Like a generalized framework that he's just applying to all of them. And that underlying operating system is exactly what we are reverse engineering for you today.
Yes, we are.
Welcome to the deep dive. Our mission today is not to just read off a resume. We are using a massive stack of source material. We're talking biographies, hours of raw dialogue from the All In podcast, TED appearances, the Bill Maher interview.
And those Y Combinator sessions too, those are gold.
Oh, absolutely.
Yeah.
So we're extracting the specific physics-first cognitive frameworks that drive this whole machine. We're going to break down the famous 5-stage engineering algorithm, his vision for Mars and robots, and distill the top 7 lessons for you.
Because whether you are building a startup right now or you're just trying to scale your own productivity, understanding these mental models will genuinely change how you view reality. Totally. And to set the baseline for this whole framework, we have to start with a quote from the sources that perfectly captures the vibe. Failure is an option here. If things are not failing, you are not innovating enough.
Which, I mean, that sounds like a classic Silicon Valley cliche.
Move fast and break things, yeah.
Right. Until you realize this mindset is being applied to rockets carrying billions of dollars of payloads. Like the legacy aerospace industry operates on a strict zero failure tolerance.
They literally cannot afford to fail. So to understand how he builds rockets and cars under the system, we can't start by looking at business strategy. We actually have to look at physics.
Yeah, it's about epistemology. How is reality itself being parsed? Which means we have to talk about reasoning by analogy versus first principles.
Right. Because, well, the human brain is naturally pretty lazy. We want to conserve cognitive energy, so we use heuristics or shortcuts.
And the most common shortcut in business is reasoning by analogy. You look at a problem, you see how someone else solves something similar, and you just make like a 5% tweak. You iterate on whatever the existing baseline is. But first principles thinking completely abandons that baseline. It's like applying Cartesian doubt to engineering,
Exactly. You strip away all the legacy assumptions, all the industry standards, all the so-called best practices, until you hit the absolute bedrock of undeniable truth.
Which, in hardware, means the literal laws of physics. Thermodynamics, classical mechanics, material science. You build your reasoning up from there and assume nothing else.
And the most visceral application of this mindset from our sources is this metric he uses called the idiot index.
The idiot index. I love this concept so much.
It's brilliant. It basically calculates the ratio between the cost of a finished product and the cost of its fundamental raw materials on the commodities market.
So if that ratio is extremely high, you're essentially an idiot for paying the retail price instead of figuring out how to just make it yourself.
Right. It measures the accumulation of inefficiency. Like, think about buying a pre-baked wedding cake for $1,000. Oh, that's a perfect analogy. Because if you know how to bake, you realize it's just, what, $15 worth of flour, sugar, and eggs?
Exactly. The massive markup is just an inefficiency you can bypass if you understand the raw materials. And he applied this exact logic to rockets.
So let's talk about that 2001 Russia trip, because that is the ultimate stress test of the idiot index.
Oh man, the Moscow trip. So you've got this young post.com exit entrepreneur, and he wants to do this philanthropic stunt to get people excited about space again.
The Mars greenhouse idea, right? Send some seeds to Mars and nutrient gel, beam back a picture of a green plant on red soil.
Right. But to do that, he obviously needs a launch vehicle. So he flies to Moscow to negotiate with these Russian aerospace conglomerates.
He's sitting in these massive, brutalist Soviet-era boardrooms trying to buy decommissioned ICBMs, intercontinental ballistic missiles from the Russian military high command.
And they view him as a total amateur. I mean, they quote him $18 million for 3 rockets. And when he tries to negotiate, they just raise the price to $21 million per rocket, just completely boxing him out. Which, I mean, most people would just hit that wall, realize spaceflight is only for sovereign nations, and go build another software company.
Yeah, but instead, on the flight back home, he pulls out a spreadsheet and just applies first principles.
He breaks down the mast of the rocket.
Yeah.
Like, what are the actual constituent elements here?
Aerospace-grade aluminum alloys, titanium, copper, carbon fiber, and he pulls up the current spot prices for those materials on the London Metal Exchange.
And when he calculates the raw material cost per kilogram, what does he find?
He discovers that the literal atomic building blocks of the rocket make up less than 2% of the asking price.
Less than 2%. Wait, so does this imply that almost every major legacy industry is just fundamentally overcharging because of bloated supply chains?
That is exactly what it implies. Complacency just becomes institutionalized. Like when the government is your only buyer and they guarantee you a profit margin on top of your costs, there is literally zero incentive to drive down the cost of materials.
The aerospace industry had just accepted this fake ceiling. They assumed because a component always cost $100,000, it physically had to cost that much.
But physics does not care about legacy pricing. Physics only cares about the material properties of the metal.
Which perfectly explains the NASA bathroom latch story from the sources. This is one of my favorites.
Oh yeah, tell that one.
So NASA had this highly specific space-rated latch for their modules, and the supply chain was charging them like $1,500 per unit for it.
$1,500 for a latch. Unbelievable.
Right. So when SpaceX needed a latch, they didn't just order from the catalog. An engineer went out, found a standard latch used on commercial bathroom stalls that cost $30. $30. They brought it back, analyzed the material strength, modified it for the vacuum of space, and it performed the exact same mechanical function.
See, that markup is entirely artificial. It's just bureaucratic bloat and certification bloat. By adhering strictly to material reality, you bypass the whole pricing structure.
But, okay, knowing the true cost of materials is just the theory. How do you actually put those materials together without just rebuilding the same bloated bureaucracy you're trying to disrupt?
And that is where most companies actually die. Identifying that raw materials are only 2% is totally useless if your own assembly line introduces the other 98% in bad engineering.
Right, which leads us directly into his famous 5-step engineering algorithm, the machine that builds the machine.
And this algorithm wasn't cooked up in some MBA seminar. It was literally forged in the production hell of the Tesla Model 3.
Oh man, the 2017 to 2018 era. They're trying to build the highest volume electric vehicle ever across factories in Nevada and Fremont.
And the production line is completely bottlenecked. The cash burn is catastrophic. He's sleeping under his desk on the factory floor.
Walking the assembly line at 2:00 a.m.
Right.
Debugging this spectacularly complex failing system. Out of that crucible, this 5-step algorithm emerges as a strict mandate.
And the sequence of the algorithm is critical, by the way. If you do the steps out of order, you actually accelerate your own failure.
Okay, so walk us through step 1.
Step 1, make your requirements less dumb. Notice the framing there. He operates on the assumption that all requirements are inherently flawed.
Like no matter how brilliant the engineer is who handed you the spec sheet, there are errors in it.
Exactly. And the mechanism he uses to enforce this is so smart. Every single requirement must have a specific person's name attached to it, not a department.
Right. You can't say, oh, the safety department requires this or legal mandated this.
Because a department is a monolith. You can't interrogate an acronym. If it has a name, you can walk across the floor, find that human being, and force them to defend the physics of their requirement.
But he also gives a warning here that I thought was fascinating. He says the most dangerous requirements actually come from smart people.
Yes, which sounds so backward, right?
It really does. You'd assume the smartest engineers write the best requirements. Why are they the most dangerous?
Because when a highly intelligent person gives you a rule, your natural psychological response is just deference. You assume they've run all the simulations and considered every edge case.
Ah, so you don't even question it.
Exactly. A mediocre engineer gives a requirement, Everyone checks their math. A brilliant engineer gives one, and it becomes gospel. The algorithm demands you question the gospel.
Okay, so once you've interrogated those requirements, you move to step 2. Delete, delete, delete.
The operating philosophy here is the best part is no part.
Because every component you add is a vector for failure. It adds mass, it costs money, it takes labor to install.
And corporate instinct is usually the opposite, right? It's redundancy. Add sensors, add brackets, add more software.
But the algorithm violently opposes that. If you aren't forced to add back at least 10% of the components you deleted, you simply aren't deleting aggressively enough.
You literally have to push the system until it breaks to find the true boundary of what's actually necessary.
Which feeds directly into the trap of step 3. Simplify and optimize. And he stresses, you can only optimize after you have deleted.
This is such a common trap. You'll have teams of brilliant MIT grads spending thousands of hours perfectly optimizing the weight and thermal dynamics of a part that shouldn't even exist.
It's like spending thousands of dollars perfectly tuning a VCR in the age of streaming.
Yeah.
You're optimizing something useless.
Exactly. And the fiberglass anecdote from the sources perfectly illustrates this trap.
Oh, this story is wild. Walk us through it.
So he's walking the Model 3 production line trying to fix a bottleneck. And he finds this incredibly complex robotic arm that's meticulously gluing little strips of fiberglass to the battery packs.
It's slowing down the entire factory.
Right. So he applies step 1. He finds the noise reduction team and asks, why is this fiberglass here? What are its acoustic properties?
And what do they say?
They look at him and say, oh, we didn't require that for acoustics. The engineering team mandated it for fire safety.
Classic corporate runaround right there.
So he walks over to engineering and says, show me the thermodynamics data on why this tiny strip prevents fires. And the engineers say, fire safety. No, the noise reduction team mandated that to prevent vibration.
Wait, seriously? Neither department took ownership?
Neither of them. They both assumed the other had done the first principles math. It's a literal Dilbert cartoon manifesting on a multi-billion-dollar assembly line.
So what did he do? Did he just rip it out?
He moved straight to step 2, deletion. They took 2 finished cars, one with the fiberglass, one without. They ran acoustic tests, thermal tests, 0 measurable difference in noise or safety.
It was ghost requirement.
Completely. So they deleted the fiberglass, decommissioned the expensive robot, and the bottleneck just vanished.
But, this kind of ignores human incentive structures. In a normal company, a manager isn't going to stand up and say, hey, my whole department is redundant, please fire us. Corporate culture rewards, adding features to prove your worth.
That's why this demands an incredibly high friction culture. Engineers have to be willing to destroy their own work for the overall velocity of the company.
Which brings us to step 4. Accelerate cycle time. Move faster.
But, again, the caveat, only accelerate after you've purged dumb requirements, deleted useless parts, and optimized.
Right, because if you accelerate a bloated process, you're just manufacturing garbage at a higher speed. As the source quote says, if you're digging your grave, don't dig it faster, stop digging.
Exactly. And then finally, step 5 is automate. And this is where he openly admits he screwed up massively during the Model 3 ramp.
Oh, the alien dreadnought picture.
Yeah, he wanted a factory so automated it looked extraterrestrial. They built these massively complex robots to do things humans can do effortlessly.
The robots couldn't handle the variance in the physical environment, right? They just jammed up.
Yeah, they ended up having to physically rip million-dollar robots off the line, leaving literal holes in the walls, and replace them with human workers just to fix the cycle time. You cannot automate a process you haven't simplified first.
Okay, so we've got the physics first mindset and this ruthless 5-step algorithm. But we need to zoom out. What is all this machinery actually aimed at?
According to the sources, the ultimate target isn't just market dominance, it's Mars.
Mars. And the push for Mars isn't just some romantic desire for space exploration. It's rooted in a really dark statistical view of the universe.
Specifically, the concept of the Great Filter. Have you looked into the Fermi paradox much?
A bit, yeah. It's basically the idea that the universe is ancient, 13.8 billion years old, and there are billions of habitable planets. So where are all the aliens? The silence is deafening.
Exactly. Evolutionary biology suggests there are these massive hurdles or filters that are almost impossible for life to pass.
And the terrifying thought is that maybe the Great Filter is ahead of us.
Right. It implies that once a civilization reaches our level of technology, it inevitably destroys itself. Nuclear war, superviruses, rogue AI, or just an asteroid.
So he views human consciousness as this tiny, fragile candle in a vast darkness. One mass extinction event and the light goes out permanently.
Therefore, the mathematical imperative is to establish a self-sustaining civilization on a second planet. You have to back up the human hard drive.
Which makes the early days of SpaceX even more intense. They are literally trying to save the light of consciousness, and their first rocket, the Falcon 1, fails 3 times in a row.
And they are burning through his personal capital. They are weeks away from total insolvency.
Because the physics of orbital mechanics are brutal. You have to accelerate a payload to 17,500 miles per hour, which means your fuel-to-weight ratio has to be perfect.
And after that third explosion, he sends that famous company-wide email, "I will never give up, and I mean never."
And the fourth launch succeeds. But getting to orbit was just the baseline, right? The real problem was the economics of spaceflight.
Yeah, how do you drop the cost of a ticket to Mars from $1 billion down to a price where you can actually build a city?
Because the legacy aerospace industry relied entirely on expendable rockets. You fly it once and it burns up or crashes in the ocean.
It's the economic equivalent of flying a Boeing 747 from LA to New York. And as soon as it lands, you just push the whole plane into an incinerator.
Oh man, if commercial airlines did that, a coach ticket would cost $5 million. Only billionaires could fly.
Spaceflight was trapped in that exact paradigm. So SpaceX realized the only way to make humanity multiplanetary was full and rapid reusability.
Which is insane engineering. You have to launch the booster, detach the payload, reverse the booster's trajectory in a vacuum, re-enter the atmosphere at hypersonic speeds, and land it vertically on a ship in the ocean.
The legacy industry literally thought this was physically impossible. They thought the fuel required to land would eat up all your payload capacity.
But by relentlessly applying the algorithm deleting mass, optimizing engines, they proved reusability.
Yeah.
And it drops the cost of space access by a factor of 100.
It shifts orbital mechanics from a government budget to a commercial budget, which sets the stage for Starship.
The largest flying machine ever built by humanity, designed to be fully reusable. And he's got a very specific timeline for Mars based on celestial mechanics.
Right. Earth and Mars align for optimal transfers roughly every 2 years. He calculates that within 10 to 15 of these transfer windows, so 20 to 30 years, SpaceX can send enough tonnage to build a city of 1 million people.
But the metric for success is stark. It's not about planting a flag and taking some footprints.
No, the test is this. If the supply chain from Earth is permanently severed, say, World War III breaks out, does the Martian colony survive, or does it die out?
Until it's industrially independent, the mission isn't over. It's a total shift from exploration to planetary redundancy.
But obviously, this invites massive criticism. People are always playing devil's advocate here.
Yeah, let me push back on this. People always ask, why obsess over this barren, freezing rock millions of miles away when we have so many immediate problems on Earth? Poverty, climate change, infrastructure. Isn't this just a massive misallocation of capital?
Well, the sources counter that on 2 timelines. First, the existential timeline. No matter how much we fix Earth, the probability of a civilization-ending event is never 0. We need the insurance policy.
And the second timeline?
The technological timeline. Surviving on Mars is the ultimate engineering crucible. You are forced to invent hyper-efficient solar arrays, closed-loop life support, advanced batteries.
Because you literally can't waste a single drop of water on Mars.
Exactly. And the breakthroughs forced by that harsh environment will inevitably cascade back down to Earth and upgrade our terrestrial infrastructure.
Okay, so if Mars is the backup plan for survival, what is the plan for human thriving right here on Earth?
The answer is a radical shift into a post-scarcity economy, driven by digital superintelligence and humanoid robots.
Enter the Optimus robot. Now, I have to ask, why humanoid? In industrial robotics, specialized forms are usually way more efficient. A warehouse sorting robot looks like a Roomba, right?
Right. Why take on the excruciating challenge of balancing a bipedal robot with a torso and finger?
Exactly. It seems unnecessarily difficult.
Because the world is already designed for humans. Every staircase, door handle, factory tool, and vehicle cabin was built for our exact morphology.
Oh, so if you build a robot with wheels or claws, you have to retrofit the whole physical world to accommodate it.
Exactly. But if you solve the physics of a humanoid robot, it is instantly backward compatible with our entire civilization. It just steps into the exact physical space a human used to occupy.
But the bottleneck there has to be the human hand. It's an absolute biomechanical nightmare.
Oh, it's arguably the hardest mechanical system to replicate. It needs like 26 actuators and 27 degrees of freedom.
Because traditional robot hands are just heavy pincers. But to pick up an egg or operate a drill, You need complex force feedback.
They literally had to mimic biology. The muscles that control human fingers are actually in the forearm, pulling on tendons.
Wait, really? The muscles aren't in the fingers?
Nope, they're in the forearm, working like a puppet.
Oh.
So the Optimus team had to build internal actuators and cable systems that replicate that exact biological mechanism from scratch.
Because there's no supply chain for humanoid robot parts. But look, all that hardware is useless without a brain. A metal hand can't thread a needle if it doesn't understand the physical geometry of the room.
And this is where everyone misunderstands his empire. People think Tesla is a car company. The sources make it clear Tesla is the world leader in real-world AI.
So self-driving is basically the foundational cognitive architecture for the robot.
Right. Large language models predict text based on the internet. Tesla's neural nets predict physical reality based on millions of hours of driving video. They are teaching a computer depth, velocity, object permanence.
And they're porting that exact neural net directly into the brain of the Optimus robot.
And to process all that data, they are designing their own silicon. The upcoming AI-5 chip is projected to be 40 times more powerful than their current hardware.
40 times. That is a massive leap. And when you combine that level of AI with a mass manufacturable body, he predicts the global economy will 10x in a decade.
He envisions a future where humanoid robots actually outnumber humans. And at scale, the cost of a robot will drop to around $20,000.
Let's talk about the economics of that. Because if you introduce a massive workforce of robots that don't sleep, don't get sick, and don't form unions,
the marginal cost of producing goods and services plummets towards zero.
It ushers in a reality where manual labor becomes entirely optional. A machine builds the house, harvests the food, makes the goods.
The necessity of exchanging your time for basic survival completely evaporates.
But this triggers a huge philosophical collision, right? The sources mention the Austrian School of Economics.
Yeah, the subjective theory of value. Value is inextricably linked to scarcity. A glass of water is priceless in the desert, but worthless if you're standing next to a lake.
Right. So if a robotic workforce makes everything infinitely abundant, what happens to human competition? If you can have everything, does anything have value anymore?
That is the uncharted psychological territory we're heading into. For 10,000 years, human drive has been tied to overcoming scarcity. If we eliminate the struggle for survival, money might disappear as a database for labor allocation.
So what becomes the organizing principle of human ambition then? Does it just become about social currency, reputation, art, intellectual discovery?
It's the ultimate question. Who are we when we no longer have to fight to survive?
Wow. Okay, so we've zoomed all the way out to Mars and global AI economies. Let's pull this massive framework all the way back down to you, the listener.
Yes, how do you actually apply this playbook to your own life and business?
The sources distill this down to 7 distinct lessons. Lesson 1, maximize your utility.
Success here isn't measured by wealth. It's an engineering formula. The area under the curve. How much positive impact you create multiplied by how many people you help over your lifetime.
You essentially just have to ensure that your net output is greater than your net consumption. Are you a positive force in the system or just extracting rent?
Lesson 2 is a bit brutal. Excellence is the capacity to take pain.
Yeah, starting a company is not glamorous. The media romanizes it, but the reality is profound trauma.
The sources document him sleeping on factory floors, showering at the local YMCA, having night terrors where he'd wake up screaming from the stress of near bankruptcy.
His advice is super stark.
Yeah.
If you need words of encouragement to start a company, don't start a company. The friction will break you.
Which feeds right into lesson 3. Work like hell. Put in the 80 to 100-hour weeks.
Is this just toxic hustle culture, though? Or is there a mechanical advantage?
It's pure mathematics. It's about iteration speed. Every prototype is an experiment. If you run the experiment faster, you fail faster, and you find the truth faster.
If you work 100 hours and your competitor works 40, you achieve in 4 months what takes them a year. The capability gap just becomes unbridgeable over a decade.
Lesson 4 is about organizational design. Collocate design and engineering.
Never separate the pristine design studio from the grease of the factory floor.
Right. He uses this great biological analogy. If your hand is on a hot stove, your brain pulls it off instantly because the feedback loop is immediate.
But if it's someone else's hand on the stove, it takes way longer to register the pain.
Exactly. If the designer is in an air-conditioned office 3 states away from the assembly line, the communication bandwidth is choked. Put their desk 10 feet from the metal stamper, and the engineering corrects itself instantly.
Lesson 5 brings us back to the start. Seek the truth through first principles.
Wishful thinking is your enemy. Constantly ask what is fundamentally true. Apply the idiot index to your own expenses. Are you paying a premium just because of legacy assumptions?
Lesson 6 is a psychological shift, a maniacal sense of urgency.
If you are slow, you are dead. Assume you are always losing. Cut out the massive meetings. If a decision takes 3 minutes on the factory floor, don't schedule a PowerPoint for next Tuesday. Time is the only true currency.
And finally, lesson 7, which is kind of the counterweight to all this hardcore physics, showmanship is salesmanship.
You have to delight your customers. Even with all the devotion to engineering truth, he deeply understands the psychology of belief.
Like the Zip2 days. He took a cheap $5,000 PC and put it inside a massive custom server chassis on wheels, just to make it look intimidating to investors.
Or the Tesla door handles that sit flush and slide out like a happy handshake. Dramatic demonstrations bypass logic and build emotional connection. And belief is what keeps the capital flowing when rockets are blowing up.
So we've traced the entire arc from the first principles idiot index through the 5-step algorithm out to Martian colonies, the AI post-scarcity economy, and down to the 7 lessons for builders.
It's a framework that requires total rejection of consensus and an incredible tolerance for discomfort.
And that actually leaves me with a final provocative thought for you to mull over. We talked about how this entire system requires extreme work ethic and enduring pain. Well, if he actually succeeds in building this utopian, AI-driven world of total abundance where no one ever has to struggle again, will that utopia make it impossible for the world to ever produce another Elon Musk?
Wow. Does greatness fundamentally require the exact struggle he's trying to eliminate?
Exactly. We are using extreme friction to build a frictionless world. Thank you for joining us on this deep dive. Keep questioning your requirements and keep building the future.